A team of theoretical and experimental physicists have designed a new ultra-thin material that they have used to create elusive quantum states. Called one-dimensional Majorana zero-energy modes, these quantum states could have a huge impact for quantum computing. At the core of a quantum computer is a qubit, which is used to make high-speed calculations. The qubits that Google, for example, in its Sycamore processor unveiled last year, and others are currently using, are very sensitive to noise and interference from the computer's surroundings, which introduces errors into the calculations. A new type of qubit, called a topological qubit, could solve this issue, and 1D Majorana zero-energy modes may be the key to making them. A topological quantum computer is based on topological qubits, which are supposed to be much more noise-tolerant than other qubits. However, topological qubits have not been produced in the lab yet, explains Professor Peter Liljeroth, the lead researcher on the project. What are MZMs? MZMs are groups of electrons bound together in a specific way so they behave like a particle called a Majorana fermion, a semi-mythical particle first proposed by semi-mythical physicist Ettore Majorana in the 1930s. If Majorana's theoretical particles could be bound together, they would work as a topological qubit. One catch: no evidence for their existence has ever been seen, either in the lab or in astronomy. Instead of attempting to make a particle that no one has ever seen anywhere in the universe, researchers instead try to make regular electrons behave like them. To make MZMs, researchers need incredibly small materials, an area in which Professor Liljeroth's group at Aalto University specializes. MZMs are formed by giving a group of electrons a very specific amount of energy, and then trapping them together so they can't escape. To achieve this, the materials need to be two-dimensional, and as thin as physically possible. To create 1D MZMs, the team needed to make an entirely new type of 2D material, a topological superconductor. Topological superconductivity is the property that occurs at the boundary of a magnetic electrical insulator and a superconductor. To create 1D MZMs, Professor Liljeroth's team needed to be able to trap electrons together in a topological superconductor. However, it's not as simple as sticking any magnet to any superconductor. If you put most magnets on top of a superconductor, you stop it from being a superconductor, explains Dr. Shawolienu Kezielbeka, the first author of the study. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.